Hey guys, we got another video for you. This time we're talking about arc lengths. So this is for the IXL, the U.3, and so here, let's go. All right, so what we got going on here is, right, this was, like I said, this is to help you with the IXL U.3. So they already have a pretty good example there. So if you've seen it, you might want to just kind of take a look. It's before the first problem. Just open it. It's something like this. This one's 180 degrees. So I wanted to do one where it wasn't exactly 180. But again, good example if you don't, if you want to see something printed out, you might want to look at that. But let's take a look at this. Now, there's a couple ways that we're going to be doing these problems. One is coming from the center angle out. So that's what this one's going to be. Okay. So in this problem, it says the radius of a circle 10 miles, right? So we've got 10 miles from there to there. We want to find the length of a 45-degree arc. All right. So again, let's just get this straight here. I got a radius here, right? Radius is 10 miles, right? So that's my radius. The arc length is 45 degrees, right? So the arc length is, so 45 degrees is the arc. So from here to here is 45. And what it wants us to do is tell us the length. Now, we have to be careful with these measures, right? Because when we say 45 degrees, you know, that's essentially saying this angle in here is 45 degrees, right? The arc itself, when it says what's the length of it though, that'd be like, gee, I've got some sort of ruler and I'm kind of like rolling my ruler along here. And how long, if I could roll my ruler, how far would it be from one end to the other in whatever units we have, inches, centimeters, or in this case, we're talking miles. So obviously this is much bigger than my piece of paper, but just keeping those units straight. Now, it's all about proportions and ratios. Now, there's a formula that we can start with, and this is the one that IXL uses, right? So they say, look, we've got L equals M over 360. Now, what it's saying is that L, right, this L, this is the arc length, okay? Right, and again, by length, right, that's going to be like inches, meters, kilometers, nanometers, you know, just some sort of length you could in theory with a you know, ruler figure out. Now the other one, M, right? M is the arc measure, but this measure is going to be in degrees. Okay? So that's like, you know, that's like an angle kind of measurement, which makes sense when you think about it, right? Let's think about this. We got measure over 360, but then this equation isn't done yet. I just getting started. We then have to multiply times C, right? So it's a little tight here. Let me draw a line here, keep this out of the way, right? So this is over here. Keep those over here separate from the formula, right? So the length equals M over 360 times C. Now C is the circumference, right? So, right, if our circumference now, we've got a couple ways we can say it, right? C, circumference, you can either think of it in terms of the diameter, pi times the diameter, or 2 pi r, right? 2 pi r, right? Now, if you ever kind of forget that formula, quick way to remember, right? Here's a circle, here's a diameter. Count your way around. Here's once around, here's twice around, bring it down here, 3 times, and just a little bit more than 3 is 3.14, that's pi, right? So you got, right, diameter, once, twice, 3 times, a little bit more, 3.14. So if you ever can't remember that, just grab your hand and a pen and you got it. Okay, so now we've got this formula. Let's figure out what we're going to do with it, okay? Now, if we look at this picture, let's see if we got things in the right order. Now, here we've got radius, right? So if I've got radius, I'm going to end up using the formula right here, which is C equals 2 pi times the radius. So what I'm going to do, I'm going to start substituting these back into here. Now again, I'm trying to find the arc length, so I like this version of it. That's simple, it's easy. So let's start putting things in. Okay, so I'm going to rewrite this with this version of the circumference. L equals M over 360, and then again my circumference 2 pi r. Okay, now I'm all good. Now sometimes I'm going to do this just because I'm going to be doing some cross canceling and stuff. Not a bad idea to just kind of think of it as a fraction, and we'll start putting things all together. Okay, so let me start putting measures in. So again, M we said is 45 degrees, right? So 45 over 360. And again, this one just kind of makes sense, right? Because think, this is 360 degrees around. Well, we're just trying to find the ratio. The ratio of how much of a circle is this, right? If this is, right, if the whole thing, right, from here to here, right, if that's 360 degrees, right, and the whole circumference, right, the whole circumference, if I, went from here all the way around, right, the whole circumference is 2 pi r, right? So it's kind of like, you're taking the ratios here. And so if you can't think of the formula, you just kind of think about what makes sense, right? It's the ratio of those two. Okay, so 45 to 360. Now 2 pi r, we know what r is, right? R is 10 miles, okay? 10 miles. Now, I'm just going to put the miles out here so it doesn't get mixed up with my everything else. But I'm just going to keep it there so I don't forget we're talking miles. All right, now notice what it said here though. Notice that it said it wants the exact answer. When it says exact, that tells me I'm going to leave pi alone. I'm not going to put it 3.14 or anything like that. I'm going to leave it alone. Okay, so let's leave that alone. And then we come down here and we're going to have to start simplifying this thing. We're going to have to simplify the heck out of it. Okay, so let me kind of see what I can simplify. Now, I notice 10 goes into this 360, right? So cross out the 10, cross out the 0, okay? Let's see, what else can I simplify here? I'm just kind of looking for things that I can cross cancel. Well, here's a 2, that's always nice. 2 goes into 36, right? So 2, and then this 36 becomes an 18, okay? It's starting to get a little messy. I think I'm just going to rewrite it just so it doesn't get too much of a mess here. So again, a lot got crossed out here. So I've got 45, I guess all that's left is 45 over 18 there. I've got a pi, and of course I've got the units of miles. Okay, now let's see what goes into those. I could think of a 3 going into that, or actually I think a 9 goes into this too, so I'm going to try 9. So I'm going to divide top and bottom by 9. So 18 divided by 9 is a 2. 45 divided by 9 is a 5. And so when I'm all done, I get 5 halves pi miles. Okay, now it's already got the miles, so I don't have to write the miles again, right? I can do this. Now, you actually have a choice. You can either use the fraction here, right? You're going to have to click on that and then make it 5 halves. You're going to then have to click on the pi to show the pi. Or, I could just write this as a decimal, and that would work too. If you put in 2.5 pi, and then the miles, of course, you're not going to type the miles because it's already there. But if you put either one of those in there, I'm pretty sure IXL is going to be happy. Either 2.5 times pi, or you could type into that box 5.2 pi. But again, it's exact, so that box is what's going right there. Okay, let's now look at another problem. All right, this is one where we were knowing the measure of the angle in terms of degrees and finding the length. Now we're going to go the other way. Now, if we're going the other way, again, now we've got that same formula, right? So I have that formula. I can write it down up here. I've got L equals M over 360 times C, right? But that's not really the way I want it, right? Because in this case, it's a little different, right? So again, let's just kind of back up and look at what we have here. Again, the diameter of a circle is 8 meters. So let me just mark everything up here. I've got a diameter of 8 meters, right? 8 meters. I want to find out what the arc is in terms of the degrees, not in terms of the length, right? So again, let me just mark this so it's a little more clear what the arc is, right? It's 3 pi m, okay? So let's come around here, right? That is my arc, right? The arc is 3 pi meters, right? M for meters, right? And now I'm trying to find this time, though, m. So this is not really ideal, is it? Now, I can rearrange this, using some algebra, but let me just give you a slightly different version, because you might not always come up with this one right off the top of your head, but this one I find is a lot easier to remember. I just set it up like a proportion. So let's just do this, right? Let's say I was starting from scratch and I couldn't remember the formula. Well, again, I'm going to think back here again, right? Let's think about ratios and proportions. Well, L is a length. L is compared to the whole circumference. So basically, you've got L compared to the circumference, right? Which is this measure M over 360, right? And again, you gotta make sure you do everything in degrees here. So, which kind of makes sense, right? You got L compared to the whole circumference, M compared to the whole way around, right? So in other words, if I was to think of it, red, right? So the circumference is all the way around, right? So that would be like over here when I went all the way around, right? See how I went all the way around? So, and then 360, of course, is also all the way around. That's why those go together. L, and then compared to M here. Now again, I just realized this might get a little confusing because I've got M's and M's. And, well, don't know what to tell you. Sometimes that happens. So be careful. Don't confuse this M with this M that's meters. Just be careful. All right, so now, again, we're trying to find M, the measure. So I don't really like this 360 down here, do I? Well, let's get rid of M. I'm just going to multiply both sides times 360, right? Just do a little algebra here, right? 360, 360, right? The 360s cancel. So I've got M alone. Now, again, this is a little messy because I usually like the variable on the left. I'm going to just rewrite this so I have it where I want it. Okay, so here I go. I've got M equals L over C times 360, which again kind of makes sense, right? The ratio of the arc length to the whole thing, that tells you essentially what fraction of the circle am I dealing with, times 360 tells me what fraction of the angle. So again, there's logic there, it kind of makes sense. All right, so let's now start substituting in our values. So we come up here, and again, I just noticed something again. Look, they want an exact answer. That means I'm going to leave pi alone. Whenever you see exact, that means don't mess with pi. Just leave it as pi. Okay, so if L is 3 pi, M for meters, right? And that pesky M is going to throw me off, isn't it? But let's just try it anyway here. So again, L is 3 pi. 3 pi. Okay. Now, C here, well, if the diameter is 8 meters, now before, we were using the formula 2 pi r, but this time we're using pi d, right? Because we know d. So be careful when you're doing that. Now, I'm just going to, before I start throwing all that stuff in there, let me just do it up here real quick, right? So if we have d of 8 meters, right, then going around this guy once, right, the circumference would be circumference equals pi times d, hence my circumference equals 8 meters times d, right? So I would have 8, well, pi, let's just say, pi times my 8 meters, okay? Pi times 8 meters. And then we come back here. Now, I just realized something. I forgot to write down that meters. I better write that. So I'm going to write down M, and boy, we're just going to have, okay, I don't know what to do about this. I'm afraid we're just going to have to be really smart about this meters and this meters. Maybe I make one of them cursive or something, right? You know, or maybe, you know what? When all else fails, you're just going to have to write it out. That's probably the safest bet. Let's just actually make it really obvious. We're talking meters and not this m. So I'm going to write it out. This is 3 pi meters, right? And then let's make the circumference rather than 8m. That actually, to be safe, you know, I'm just gonna wherever I see m for meters, I'm gonna write it out because I just don't want to get confused here, because that's a problem waiting to happen. So I've got pi times 8 meters times 360. Well, hey, look what I get to do. And this is what's cool about keeping things in pi, is that suddenly things get to cancel each other, right? Look, pi cancels, pi cancels. I get 3/8. That's pretty nice. Oh, look what else is going to cancel here. Meters. Meters and meters cancels. Things are getting easier by the second. So I've got 3/8 times 360. Now, let's see. 8 goes into 360. Let's see if I can remember that. Well, I know that 4 goes into 360. Let's just do that one because I can do that one off in my head, right? So 4 goes into 8 twice. 4 goes into 360, right? Because 36 divided by 4 is 9. So hence this is 90, right? Oh, but wait. That's pretty cool because I know how many times 2 goes into 90, right? 2 goes into 90 45 times. Okay, it's getting kind of messy. Let me rewrite it because things are starting to get really messy here. I've got m equals, boy, there's not much left, is there? Look, here's a 3 times, that's canceled, that's canceled. The only thing that isn't canceled is that 45, okay? Well, 3 times 45 turns out, right? 45, ooh, let's do that again, right? 45 times 3, 15, carry the 1, 3 times 4, 12, 135. Okay, so m equals 135. Okay, let's double check our units though. Remember, this was m in degrees because this is 360 degrees. And they're asking for degrees. Okay, so we're good. So basically what I would do is I would take this and I would write that into this box. Well, I'm going to type it in, obviously. That's what goes in that box. 135 is what goes in that box right there, right? So this answer we just got from here. All right, so I hope that helps you guys. And if you got any more questions, just let me know. Other than that, have a good one. See y'all later.